Welcome students. In this video, we are going to discuss about bottom-up parsing and also about shift-reduce parser. So bottom-up parsing is a process of constructing the parse tree from leaf node to root node. When compared with the top-down parsing where we will be constructing the parse tree from root node to leaf node. So before getting into detail about bottom-up processing, we should have a clear idea about what is the purpose of the parse tree. The parser constructs the parse tree to validate the given input string. So whenever we give an input string to the parser will be validating whether that input string is with proper syntax or not by constructing a parse tree. If the parser could construct the parse tree completely, or if the parser could construct a valid parse tree, then it means that the given input string is with proper syntax. Suppose if the parser couldn't construct a valid parse tree for the given input string, it means it is not the given input string is not with proper syntax. You have some errors in it. That is the meaning of it. Right. Now let us proceed with bottom-up parsing. So in bottom-up parsing, as we discussed earlier, uh, we will be constructing the parse tree from leaf node to root node. The process is initially we will be taking the input string, and then in the input string we will be trying to identify a substring, and then we will be matching that substring with the production available in the grammar. If the substring matches with any production, then the substring will be replaced by the corresponding productions non-terminal. Corresponding productions left side symbol. Everyone knows that in a production rule, you will be having a non-terminal in the left side, then you will be having some pattern in the right side. So we are initially we are just starting with the input string. In the input string, we will be identifying a substring, and this substring we will be identifying it starting from the left side onwards. So once after identifying a substring, we will be trying to match with the different production rule. If it matches with any production rule, then the substring will be replaced by the corresponding non-terminal in the production. So the substring whatever we have taken is what called as handle. And the process of replacing the substring with a non-terminal is what called as reduction process. Okay, to summarize, we will be identifying the handle, then the handle will be replaced by the corresponding matched productions non-terminal. Okay, so if you couldn't get it, just go through the example. Okay, so with that example it will be very clear for us. Now let us consider that we have a grammar like this. Now with this grammar, we are going to construct a parse tree for the input id star id. This is the input string id star id. So for this input string, we are going to construct the parse tree. So in bottom-up parsing, as I said earlier, we will be identifying the handles. So let us consider that id is a handle. This id is a handle. Now next what you have to do, you have to compare this handle with the production rules, and you have to check with production rule it is matching with. So this handle id is matching with the production rule f tends to id. So what we can do is we can reduce this id as f. So that is what happens. The id, the handle id is being reduced as f. Again, next what you can do, again you can consider f as a handle and just check which production matches with this handle f. You have a production like t tends to f. So this production matches with this handle. So what we can do, this handle can be reduced as t. That is what happens next, t. Okay, so f is been reduced as t. Now what we can do is we can try to have T as a handle. So if you have T as a handle, then what happens is that you have a production like E tends to T. So T matches with the handle, right? So what we can do is we can reduce the T as E. But if you do so, what happens is that let me just show you just a minute. So we can have like E, the T reduced to E. You can have like this. But the problem is, of course, E is an starting symbol. So from this symbol, we can travel to T, F and ID. But there is no path from E to ID or E to star. So we should not choose T as a handle. We should not choose T as a handle, right? So next what we can do is we can try to consider some other substring as a handle. Now let us try to have it as T star ID. When you have T star ID, no production will be matching with it. So T star ID can't be a handle. So let us try to have ID itself as a handle. So when you have ID itself as a handle, yes, ID is matching with the production F tends to ID. So what we can do? We can replace the ID with F. We can reduce ID as F. That is what happens next. ID as F. Is it okay? Right? So next what we can do? Again, the T star F, you can try to have it as a handle. When you have T star F as a handle, do you have any matched production for it? Yes, you have a production. T tends to T star F. So what we can do? This T star F can be reduced as T. T star F is reduced as T. And finally, again, this T can be reduced as E. Like this you can. So this process we have to continue till we end up with the starting symbol. So for this grammar, E is a starting symbol. For every grammar, we'll be having some starting symbol. So we have to continue this process till we end up with the starting symbol. Now this is the parse tree. So how we have considered the parse tree? From the leaf node, we reached the root node. So this is what called as bottom-up parsing. Hope it is clear for you. Now next we are going to discuss about shift reduce parser. So shift reduce parser is a type of bottom-up parsing. Okay, now let us discuss about it. So in shift reduce parser, as I already told you, it's a type of bottom-up parsing. So it means that we are going to consider a parse tree from leaf node to root node. In shift reduce parser, what we're doing is we'll be just using stack for implementing for the purpose of considering a parse tree. We'll be making use of a stack. And in shift reduce parser, mainly we will be doing two operations. One is shift operation, another one is reduce operation. So shift operation means just shifting the current input symbol to the stack. When we say shift operation, when we say that we are performing shift operation, it means that the current input symbol is being pushed to the stack. And the second operation, reduce, means we are replacing a handle in the stack with a corresponding non-terminal. I'll repeat upon. Reduce means in the stack we will be trying to have a handle. You can relate with the handle what we discussed in the bottom-up parsing. So we'll be trying to form a handle, and then the handle will be replaced by some non-terminal, right? We know how it will be replaced. This handle will be matched with the production, different productions whatever we have in our grammar, and whichever production it matches, the handle will be replaced by the corresponding non-terminal in the production. The same thing. In reduction, what happens is that a handle will be formed, and that handle will be compared with different productions. So whichever production it matches, that production's non-terminal will be replaced as the handle. So these are the two operations we'll be performing in shift reduce parser, shift and reduce. Okay, so shift reduce. So we will be doing this process till we have uh, the empty stack and also all the input symbol has been processed. So once if you process the entire symbols in the input string, and also if our stack is empty, so it means that our input string is a valid one. Our input string satisfies the syntax. Suppose if input string has been completely processed, but if the stack is not empty. Suppose if you stuck in between in the sense you had a handle, but you don't have any production which matches with the handle. So in that situation, you cannot proceed further, right? So if you couldn't end up with an empty stack and all the input symbol processed, it means that the input string is not with proper syntax. So if it is not with proper syntax, then it means that it is an error. Then you have to handle that error. Now let us discuss with an example. Just consider that we have a grammar, the same grammar what we discussed for our previous topic, that is whatever passing, the same grammar we have. And let us take the same input string id star id. So initially what we're doing is that we have a stack with us, and in the input field you have the input string id star id, right? Now the point is that in our stack we will be having a dollar symbol in it. So a dollar in the stack refers to an empty stack. The last symbol of your stack will be dollar. So initially dollar will be in your stack. So it means that your stack is empty. Similarly, at the end of the input, we'll be having dollar just to indicate that it is the end of the input string. Hope it is clear for you. Now we have to process the input symbol one by one. Now initially our input string will be the current symbol will be ID1. Why it is ID1? Because in whatever passing we will be processing the input from left to right. So first one is ID1. Now if your stack is empty, then what you can do is the input symbol you can just push it in your stack, and that operation is what called as shift operation. Now the earlier slide we discussed, now we have two operations, mainly two operations, shift and reduce. What is shift? We'll be shifting the input symbol from the input string to the stack. So that is what we have to do. So when we have to do this, if the stack is empty and if the current pointing symbol is an a terminal, you can just push it, right? Yes, fine. Now next what you have to do is you just shifted it. So once after shifting it, what happens now? What is your current symbol now? You have star here. The current symbol is star. And then in your stack you have some content in it. Now next what you have to do is you have to check whether this current symbol, the topmost symbol, is matching with some production rules. What I'm trying to tell is you just try to have a handle. You just try to consider ID1 as a handle. Yes, I'm just considering ID1 as a handle. Now next what you have to do, I have to check whether this handle is matching with any production rule. Yes, it is matching with the production rule. What is the rule? F tends to ID. So what I can do is F tends to ID. Right? F tends to ID. Now what I can do is I just go for reduction operation. Shift reduce operation. Reduce. What does it mean? This handle you are just replacing with the corresponding non-terminal. So that is what the next step you will be doing. You will be replacing the ID with ID1 with F by using the production rule. F tends to ID. Next, what you can do, again you can try to replace this or reduce this F. Just check whether any production rule is matching with this F. Yes, you have a production rule. What is the rule? What is the rule? T tends to F. T tends to F. So what you can do, by using that production T tends to F, you can just reduce that F as T. Okay, fine. Now it is been replaced. Still your current pointer is pointing to star. Now next what you can do is, uh, instead of reducing it further, okay, what you can do is you can just perform the shift operation. Okay, so you have a star here, right? So you can just shift it to the stack. Okay, so yes, I have shifted it to the stack. Now current pointer is pointing to ID2, right? Now you can try to go with reduction operation, but you don't have any pattern matching or any production matching with this. So again you can go for reduction. Sorry, again you can just go for shift operation. This ID2 can be shifted to the stack. So when you shift it to the stack, what happens? You're just getting the result as T star ID2, right? Now once after shifting it to the once after shifting it to the stack, next what you can do, now you can just consider the ID2 as a handle. ID as a handle. Now once if you have ID as a handle, next what you can do, you can just see an production which has ID in the right hand side. Which production you have ID as a right side? In F tends to ID, right? So what you can do, since F tends to ID is matching with this, you can reduce ID to as F. Already you have T star. Now this ID2 is being replaced as F by using the production F tends to ID. Now what you can do, now you can just consider this T star F as a handle and just see whether you have any production with T star F in the right hand side of the production rule. Yes, you have one production. T tends to T star F. So what you can do, this T star F can be reduced as T. T star F can be reduced as T. And again, this T, again you can just reduce it to F because you have a production like E tends to T, right? So by using the rule E tends to T, you can just reduce this T as E. You started with the input string, and by applying shift and reduce operation, you have ended up with the starting symbol E. Okay, you ended up with the starting symbol E. Okay, now at the end, you should have the dollar symbol in the input string, and in the stack, you should have only the starting symbol. Okay, so it means that with the starting symbol, you can reach all the leaf nodes. So it means that the given input string is matching with the pattern given by this grammar. Okay, one point with what I said earlier, with the beginning of the shift reduce parser, I just said like uh, at the end of your shift reduce process, you should end up with empty stack and all the input string is processed. But actually what should happen is that all the input symbol should be processed at the same time. In the stack you should have the starting symbol, not the empty stack. In the stack you should have the starting symbol. So if you end up with the starting symbol, the starting non-terminal in your stack and all the input symbol processed, it means that the given input string is a valid one. Now in this case you are ending up with a valid one, right? It means that ID star ID is a valid one. Okay. Uh, Now in the shift reduce parser, you may have two conflicts in it. The conflict in the sense, while processing the input symbol, there may be a possibility that you can go with either shift operation or you can go with reduction operation. Okay. or in a particular situation you may have more than one reduction options available. Okay, so such conflicts will be having with some such conflicts. Okay, so these conflicts you can overcome with the other type of parsers. Okay, we have LALR parser. So using those parsers we can overcome these conflicts. Okay, I can just give one example for this conflict. When we are having, when we in the stack, when we have T, what we can do, the current input symbol is star. Okay, and in the stack you have T. Now either you can go for shift operation or you can go for reduce operation. Of course, in our example we can go on for shift operation, but instead of shift operation you can also go for reduce operation also. This T can be replaced by E, but we have gone for this. So this is what we are calling as conflicts. So we have both the possibilities, but out of that we are just choosing the best possibility. Okay, so that's it. We will discuss the other type of passes in our next video session. Thank you, students.